functions. So it gets a little bit more difficult problem. So let's write out what this one's looking for. It's looking for the cosine of 2 theta of the angle whose sine value is 1/4. Okay, now this is an identity you don't know, so I'm going to give this one to you. So cosine of 2 theta, and since they only give us sine information, cosine of 2 theta is equal to 1 minus sine squared of theta. So we have 1 minus, they gave us a sine value, 1/4 squared, which gives us 1 minus 1/16. So if I change this so we have a common denominator, it's 16 minus 1/16, which gives us 15/16. So the cosine of 2 theta is 15/16. It's the identity. This is on your cream sheet of paper. They have more than one. We use this one because it only gave us a sine value. So I do need to throw this in here. That is cosine of 2 times the angle whose sine value is. So we had to use our identities. Okay, this is another identity that we have. Notice that we have sine plus cosine, but this is not the part. We have, this can be written as cosine of a plus b, which again is an identity, and the identity on this one is cosine of a times cosine of b minus sine of a sine of b. Now at this point, unfortunately, we have some work to do. So we're going to identify this being angle A and this being angle B. So for angle A, our x, y, and r values, y is 3 and r is 5. And this is going to be a 3, 4, 5 triangle, so x is going to be 4. And B, x equals y equals r. R is 13, cosine is x, so that's 5. And if you remember your Pythagorean triples, this is a 5, 12, 13. Now you can use the x squared plus y squared equals r squared if you must to find these values. So we're going to use this formula. So cosine of A times cosine of B minus sine of A times sine of B. So cosine of A is going to be 4/5 times cosine of B, which they gave you, 5/13, minus sine of A, which they gave us, times sine of B, which will be y/r, 12/13. So we get 20 minus 3 times 12 is 36. And 5 times 13 is 65. And 20 minus 13 gives me negative 16/65. And that is our answer. Again, stuff that we did, I don't know, chapter 2. This is, yes, I get it. This is an identity that we haven't covered, but you won't see it that often. This is kind of those that Those of you moving into calculus, if you needed it, they would give it to you. They say, oh, hint, blah, blah, blah. Obviously, that's a hint to use it. Okay, so this one is very, very similar to the last one, only this time they gave you, we're looking for sine, and we have A. Remember, this is the angle whose sine value is 1/2, and this is going to be B, the angle whose tangent is this. So for angle A, x equals y equals r equals so the x value over here we don't know. This the r is 2, y is 1, x squared plus y squared equals r squared, x squared plus 1 equals 4, so x squared equals 3, so x equals plus or minus radical 3. We will assume quadrant 1 unless they tell us otherwise. Angle B, x equals y equals r equals. Now, we can do this bit. So we don't know which one has the negative. In all honesty, we don't have a clue. When they gave us tangent, we're like, oh, which one's which? So this is y over x. So we're going to go with -3, 1, x squared plus y squared equals squared. So we get 1 plus 9 equals r squared. So 10 equals r squared. So r equals square root of 10. This we know is positive. So our special case on this one, if you have sine of a plus b, it's going to be sine of a cosine of b plus cosine of a sine of b. Okay, so sine of a they gave us 1/2. Cosine of b will be 1 over radical 10 plus the cosine of a, radical 3 over 2, times sine of b, -3 over radical 10. So we get 1 over 2 radical 10 minus 3 radical 3 over 2 radical 10 is 10. Or 1 minus 3 radical 3 over 2 radical 10. And you do not have to fix that. And there you guys have it. So this is the end of the second one, a little bit more. These are all on your cream sheet that has all of the different identities on it. It's a formula, just like law of sines, law of cosines. They're formulas. Okay, and again, repeat, here's your homework, and good luck.